let's assume that question says 9 says f of x equals 2x squared. And it wants you, we'll just do it in order here. So let's find the average rate of change from 2 to, well, let me write it the way that the instructor is, from 2 to 5. So let's start with the average rate of change from 2 to 5.
Okay.
So one option is like I can start working it out if you don't look at the screen, or I can wait until you get a little bit going on it to start working it out.
Let me get it going first a little and then.
Okay. Now you wrote this on the exam. I'll at least put this up because this is totally correct. F of B minus F of A over B minus A.
Two to 5. Okay. Oh, I see what I did wrong. 8. 14.
Could be. So F of 5 is 2 times 5 squared. That's 50. F of 2 is 2 times 2 squared. That's 8. And so if we use our formula over here on the right, that's 50 minus 8 over 5 minus 2, which sounds a lot like 14.
Good. Okay.
Okay, so this is the next one. So before we go on to the next one, do you remember the definition of the derivative, which is the difference quotient limit thing?
Okay, so limit as h approaches 0, and then on the numerator f x plus h
Yes.
minus f of x over h. Yeah.
Great. So let's just do this in pieces, even though the question will, it won't be like this steppy. So, but do this first for that f of x equals 2x squared, please.
Okay. Okay, so for x.
Yes. So dot, 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 f prime of x equals 4x. So the question, let me type the question here so you can see it. We would say find the instantaneous rate of change at x equals 3. Okay, so
Okay.
you have done, you have done, right. So you would have to put 3 in here. You get f prime of 3 equals 4 times 3, which is 12.
Like once you get to that step, if you get it wrong, it would be so sad.
Well, it does happen. So you really want to pay attention to that. So let's go to 15 and do one like it. It's very similar. And I'll say given f of x equals x squared plus 2x. Okay. The question part A, well, let's not even get to that. Yeah, let's just have you, I want you to find f prime of x using the definition of the derivative, which is the limit thing.
Yeah, okay. Limit. Mhm. Okay. So I got 2x plus 2.
That is correct. Okay, so your derivative is 2x plus 2. That's great. All right, so let's look at, let me write out what the question would actually say here. It would say, find the equation of the tangent line at x equals, I'm sorry, at 1, 3. Okay. Now, maybe your instructor talked about this, but how they have to give you one of these points, and they sometimes just give you x. They got 3 by putting 1 into the original. I'm sorry, 3 by putting, so they take this 1 here and they put it up here, and that's how you get 1 squared plus 2 times 1. That's how you get the 3, in case you're wondering.
Okay.
Okay, so you need the equation of a line, and the line you generally want to use this one: y minus y1 equals slope x minus x1. And you need 2 things. You need a point, which you have, 1, 3. And the second thing you need is a slope, which is the derivative. But you don't need the derivative function, you need a value. So you get that value by, do you remember putting 1 into that? Position.
Oh, okay.
So there's a lot of steps here.
Wait, why? Oh, I see. Okay. So it'd be like 2 times 1.
Yes, the slope is 2 times 1 plus 2, which is 5.
4.
4. Yes, 4. I've been out in the sun a little too much today. Okay.
And then it's y minus 3 equals 4, x minus 1.
Right. And this is less important now, but you just leave it. You don't need to simplify.
And then the tangent is the same, just negative 1/4.
Now the normal would be y minus 3 equals negative 1/4 x minus 1.
Oh, yeah, that's what I meant. The other one is the tangent.
Yes. Okay, so I had suggested that you do those on your own, and now we've done them together. I can start giving you other questions that are like the ones on the test, but you can also say I'd like more like, this one, whichever one that may be.
Let me see if there's any in particular that I want to maybe. Oh, can we do one like 7, 6, and 7?
Yes. Okay. All right, let's do a small variation on 6. We'll start with that. So 1 like 6. So we'll do the limit as x approaches 4, x squared minus 16, and then x squared plus 5x plus 1. Okay. And then I'm just going to put this over here. And then there's the limit as x approaches infinity for the same thing. And we want to see how these are the same and how they're different.
Okay. X plus.
So are you doing this one by hand also?
Yeah.
Okay, I
How
just,
do you,
oh, I'm sorry. I totally messed this up.
I was
Sorry. I'm so
okay.
sorry. Um,
I was like, I don't think the top is factorable.
it is not. Now it is.
Okay.
Now it is. That 4 makes a huge
Or
difference.
so I can do that now. Or gosh. Oh, minus and minus. That's shouldn't it be x squared minus 5x?
No, the top factors to x plus 4, x plus 1. And the bottom is x minus 4.
Minus 4x plus 4. Okay, yeah. So then you plug in 4. So 4 plus 1 is 5 over 4 minus 4, which is 0. Does not exist.
Well, why do I keep doing this? Yeah, I keep giving you the wrong number. It's negative 4. I guess that's what it was in the problem. I couldn't
Okay,
see it.
so
Okay. The whole idea here was that you cancel those and you get the limit as it's approaches negative 4 of x plus 1 over x minus 4. And then you put those into the original.
yeah. So negative, yeah, 3.
So you have to be able to factor and then do it. So sorry about that.
Oh, good. I don't remember why I couldn't. Okay.
On the right, there's nothing to do on the right. Like you don't have to do any. You don't have to do any factoring. I guess is what I should have said, and that's what's wrong there. Because now you're just looking at the ratio of the coefficients.
Right. So because they're the same, it's 2.
It's the ratio of them, of the coefficients, not the powers, the coefficients.
Oh, so it's 1.
Yes. Okay. Now, what if it was the limit as x goes to negative infinity, x squared plus 5x plus 4 over x squared minus 16. Would that change anything?
Well, there's a negative infinity. I don't think so.
Say that one more time. It's the same as this because it's always the ratio of these coefficients.
So it doesn't matter, right?
Right. Because if you have a negative number and you square it, you get a positive. If you negative number, you square, you get a positive. If it was cubed, they would just cancel out. The signs would cancel out.
So it doesn't matter what power it is, even?
As long as they match, it's always the ratio.
Yeah. Okay.
Okay. How about there's this problem? I know we're gonna get to 7, but there's this problem towards the end, 16. I'm just gonna do one like it. It said f of x equals 1 plus 3e to the x over 1 minus e to the x. And the first thing it asked for was the the limit as x approaches minus infinity.
So you.
So it's kind of the same deal. It's a ratio thing, but this one's deceptive because
So is it 3 because it's 3 because you
well,
tried to order them?
let me remind you, e to the minus infinity is 0 and e to the infinity is infinity.
But why does that matter? Don't the e to the x's have the same power? So just be like.
Well, so at minus infinity though, this thing goes to 0 and this thing goes to 0.
Because you're plugging in.
You're plugging in minus infinity into e to the x. Okay, so the limit as x goes to minus infinity of this thing, let me write it. It's 1 plus 3e to the minus infinity over 1 minus e to the minus infinity.
Oh, so those becomes, so it's just it just becomes 1 over 1.
Right. Okay. And then where this is challenging is when you do the limit as x goes to infinity. It's 1 plus 3e to the infinity over 1 minus e to the infinity. These ones don't matter now all of a sudden, and it's just the ratio of these.
But why couldn't you do that for the minus infinity one? I don't.
So minus infinity goes to 0. So let me.
But why on the last example that we did, even though it went to minus infinity, we could do it?
Because it was a polynomial, not an exponential.
Oh.
So this one we just did is really like 1 plus 0 over 1 minus 0.
So anything with like an e, it's not the same rules.
It's not the same rules, but it kind of is in this case. In this case, it is. It becomes minus 3. I'm sorry, positive 3 over minus 1.
So minus 3. Okay. That makes sense.
Okay, so let's do another one like this. So it's the limit as x goes to negative infinity, 2 plus 4 e to the x over 3 minus 2 e to the x.
Okay. So I'm going to plug in 2 plus 4. 2/3.
It is 2/3. Okay, now I'm going to ask the other one, right? The limit as x goes to infinity, same thing here, 2 plus 4 e to the x, or 3 minus 2 e to the x.
-2.
Yeah, because it's 4 over -2. So what I'm concerned about, and I mean, maybe it won't matter because they truly will just change numbers, is like I could scramble this slightly so it's still the same type of problem, but would you know, like, do you think the instructor will just change the numbers like I did here, or scramble it, meaning like reorder?
Probably just change the numbers, honestly. Because there's only like 2 of us retaking the test, so
Okay.
you're gonna put that much effort into it.
All right.
But I mean, if it was scrambled up, you would still just look for the ratio of like the e's, right?
Most likely, yeah. So, but here's the thing. So here's like there's also some other small variations. Let me do this one. Limit as x goes to infinity, 4 plus 2 e to the x, negative x, over 6 minus e to the minus x. So now when you put minus, or when you put infinity in here, it becomes 4 plus minus infinity, right?
Right.
And then e to the minus infinity is 0. So it becomes this.
Okay. Yeah, I don't think he'll do that.
I mean, there's like just little things like that that all of a sudden it's like, oh, these aren't quite the same.
He'll probably just change the numbers. I don't think he'll do something like that.
Okay, let's go back to, let's do this one here. Actually, let's do this one. One last question on this.
Okay.
Limit as x goes to 0.
Okay. So e to the 0.
So e to the 0 is always 1, or e to the minus 0 is always 1 also.
That helps. Okay. So then that's 4 plus 2. 6/5.
Yes.
Okay.
It becomes, let me write it out in case you look at the slide. 4 plus 2 over 6 minus 1. What you just said is 6/5. Okay, great. So now let's go to 7. And let me just grab the piecewise function and then ask you to do some things with it that will help you better understand what might be true or not true, because it'll be asked differently. So let's do this. Let's find the limit as x approaches 0 from the left, f of x. So you figure out where 0 is, and hopefully you say, okay, 0 is there. Well, which one is valid left of 0?
Left of 0.
Yeah,
The first
one. So that like f of x takes on all these, but you're effectively looking at x squared minus 1 as your function.
Then do. So you just plug in 0 for that. So it's
Yep.
-1, right?
Mm-hmm. Okay, so now let's do another one here. Let's do the limit as x approaches 0 from the right. Now, hopefully you've got this up because I'm gonna have a scrolling issue here shortly. So which one is valid from the right?
0.
Right of
Second one, 2x.
2x. So this becomes 2 times 0, which equals
0.
Now, what is f of 0? What is the function evaluated at 0?
It does not exist.
So there's no place. Here's what you just told me. You told me there's no place where you can put 0 into this thing. There's no place with the underline.
Oh, x squared minus 1.
Yes.
But I thought, when is it that if they don't match up, they're like, it does not exist?
We're getting to that, but we're doing
okay.
that, like we're doing the limits first. Like basically this is the left, this is the right, and then the next one is like at the point.
Okay.
Okay, so the limit exists. The limit exists if these are the same. Are these the same?
No.
No. So the limit does not exist at that point. Okay.
Right. Yeah.
All right. So let me copy it down. Actually, there's enough room to do this. We'll try this for the next one. So the next breakpoint is at x equals 1. So we need three things here. We need the limit as x approaches 1 from the left, f of x. So from the left means you find 1, there's 1, there's 1, there's 1. And which one is valid left of 1?
2x.
2x. So this is your 2x. So this is 2 times 1, which is.
How do you know which, like, how did you decide to do 0 and 1? Is it just because it's like defined there?
It's the breakpoints. See, I
So
was
it'd be
like,
what? It would be 0, 1, and 2.
yes, and you can see where we're going. We're going to do 2 after 1.
Okay. Okay.
When you understand how I'm picking them, it helps you to understand like what could be asked and then like what you
But
mean.
do you need to do this whole like for like the question when it says like,
No,
if
no,
of,
but see how it says which of the following is false?
yeah.
That's really hard because then you got to do like everything.
So you do have to.
No, you don't need to do all this, but like A is just asking about something at 2, B is asking about something at 1, and well, I guess you do have to do them all. I'm having you go through this so that you have a better understanding of.
No. It's good that we're
Yeah,
going through.
okay,
it.
okay.
I just wanted to clear.
The answer is no. You don't have to do all this. You would look at what is A and then go do the stuff for A, which is at 2, B is at 1, and then D is at 0. And C
Okay.
is at 0.
Well, you really do because that's
Yeah.
that's the 3 main points. Okay. Anyways.
Okay, so let's do the limit as x approaches 1 from the right, f of x. So from the right, you got to figure out, which function that is. And that is this one down here.
Yeah, 2 negative 2x plus 4. That's negative 2 times 1 plus 4. 2.
Okay, and then the last one here is f of 1. So it's wherever x is defined at 1.
So it's 1.
It is 1. So in the previous problem, we did it at 0 where it's defined at 0, and here it was exactly equal to 1. Let's just say, I know it doesn't ask it, let's just say I wanted f of 3. Is the function defined at 3?
No.
No, so this would actually does not exist.
So then in this case, in the x equals 1 case.
So are these the same?
Write, yeah, so you'd write like limit as x approaches 1, f of x equals 2, right?
Yes. Okay. Yes, very good.
And then you do it for 2, so
yeah, we're going to do the same thing at 2. So let me copy this down. I'm being really formal with the notation. You can just, you don't have to write all this. You just have to get the numbers and make sense of them.
yeah. Okay. Cool.
Okay, so that takes care of 7. What type of problem would you like to do next?
Can we go over 1 again? I don't remember what I.
Sure.
Oh wait, I remember. So it was like the limit, or no, whatever your y equals. That's what your limit equals.
That's the limit,
right?
is that, yeah, as x approaches infinity. Yeah.
Okay.
It's whatever your horizontal asymptote is.
Don't need to go over that. see, maybe. Oh, what about? Four? That might be hard to come up with another one, but
Yeah, we can do this for sure. So let me make up a new one here. This is
and then after that, the beginning part of the no calculator. I mean the calculator.
okay. So let's say f of x equals x plus 3 if x is less than or equal to 2, and 2x minus 6 if x is greater than 2. Okay, let's just do some things here. Let's do the limit as x approaches 2 from the left. Give me that value. Give me the limit as x approaches 2 from the right, f of x, and then give me f of 2.
Okay. So from the left, we're going to do first one. 3, 2. So 5 for the left.
Okay.
And then, is that right?
Yes.
Okay. And then for the right, you're going to do the other one, 2 times 2, -2.
Okay.
And
then how about at f of 2? What is f of 2 equal to?
2, it's 2 plus 3, 5.
Okay. So are these two values the same?
No.
So the limit does not exist.
Yes.
Okay. So that's one concept to think about. Let me look and see what it actually asks here. See what other things I can ask you to do. Okay. So since the limit does not exist, meaning they're different numbers, that's called a jump.
Oh, that's a jump?
Yeah, a jump is when the limits approach two different values. They have to approach values, numbers. I'm holding my hands up as if you can see. they approach two different numbers. 5 is not the same as -2. So it's like if we were to graph this really quickly, and we're doing this at 2, from the one side, let's assume that that's 5, and from the other side, that's -1. Like from the left, it approaches that value, and from the right, it approaches that value.
So what is a vertical or horizontal? How do you know it's that? How would you know it's a vertical or horizontal?
I'm sorry, say that one more time.
How would you know, like maybe not in this specific problem, but like how would you know if something is a vertical or horizontal asymptote rather than jump?
So you know the answer to this, maybe just need reminding of you of it. So the vertical asymptotes are when the denominator equals 0. Really has nothing to do with limits.
Oh, okay.
It kind of does. So like, let's just say there's a vertical asymptote at x equals 3. Okay, that means that, but here's the problem. It's like there's a couple of possibilities. It could be something that looks like that and that, or one could go down and one could go up, or one could go up and one could go down. And that's like beyond the scope of, I think, what you're doing in this class.
Okay.
You're going to get some curve sketching stuff later on, but nothing at the moment.
Okay. So then it is a jump.
It is a jump. Okay. So let me give you one that is not a jump,
Wait,
if you want. Go ahead.
it's not continuous, right? Because it
Yeah.
doesn't exist.
Yes. Let me try to, I think I can maybe help you here. So if something is continuous, and this is the best case, if something is continuous, the limit exists. Okay. If it's not continuous, there are a couple of possibilities. One is a hole. Here, the limit exists also. The second option is a jump, and the limit does not exist. The third is a vertical asymptote. And this one, I don't really want to put anything down here because the limit could exist, but it could be infinite. That's a
So for a hole, like I wrote, like it's when it cancels out, right?
it is, or so a hole could have this possibility. Let's say it is a hole at x equals 2. The limit as x approaches 2 from the left equals a number, and the limit as x approaches 2 from the right, it's the same number, but f of 2 equals a different number.
Okay.
So it's like from the left, from the right, but then it's defined down there.
Okay, got it.
Okay, let's go to, you said the first non-calculator question or one,
Oh,
or
just
10
like,
or 11.
Maybe start with 10 and just work our way down.
Okay.
We don't have that much time, but however many we can get through.
So hard thing with 10 is I'm not really sure how else your instructor would ask this.
Maybe
So
changing the exponents.
the thing is it could be, if you go to cubes, yeah, let's do that. So let's do the limit as x goes to a, x squared minus a squared over x minus a. Let's try that one. So the
Okay.
problem here is when you put a in for x and x, you get 0 over 0.
Oh. Yeah.
So the first option is to try a as x, but you also know to factor.
Oh, right. So you do the top. So it's x minus a, x plus a, and then the x minus a's cancel.
So this
And
becomes the limit as x approaches a of
x plus a, and then you plug in your a.
That's right.
So then that's a plus a, which is 2a.
Right.
Not a squared, 2a.
Right. So the only other type of factoring that I could see here would be sum or difference of cubes. I can't say for sure that it would be here, but that's that. I mean,
remember how to do that.
Right. Right.
Oh, okay.
Okay, so let's go to 11, and I'll make up one like that. So it's the limit as x approaches 0, sine 4x over 1 minus e to the x. So the issue here, like 10, when you put 0 in for x, you get sine 0 over 1 minus e to the 0, which is 0 over 1 minus 1, 0 over 0. This is bad. Okay.
E to the x is like a big number, right?
It is. So you have a calculator though here. So one option is to graph. Okay. Another option is to use the table and pick values close to zero. Close to zero on both sides though.
What
Which-
mode should your calculator be in? Degrees?
Radians. Unless you take an introductory physics class at some point, it's going to always be in radians for the rest of your math classes.
So if we do y, sine of 4x.
Make sure you get those parentheses around it.
Over, oops. Divided by 1 minus e to the x. Oh, so then you have to find out like where it's approaching.
Yeah, so the graphing isn't so good for a lot of times, but your instructor gives you numerical values, so it might be okay.
But it looks like weird. It's like,
Yeah, it's really weird.
so how do you find that whatever you're looking for? What am I looking for?
Well, I think, and I made this mistake. I ended up with some extra parentheses or something. The problem is you probably want to just put values in really close to zero.
I
0.0001.
do that, really.
Okay. All right. Let me.
So where do the parentheses have to be? So it's like, is it parentheses sine parentheses 4x?
Yeah. Let me write it. Let me write it down here. So it would
I
be
want to make sure that I
sine parentheses 4x slash parentheses 1 minus e, and depending on your calculator, it either goes like e caret x, like that, or maybe you can get it up there. I don't know.
Oh, you have to put the x in parentheses too.
Well, it depends on what it does. Like this is where it's a function of your calculator. Now you got to think you've got an 84. Like
Yeah.
you have to see how there's two open.
Oh, it looks, I did it right. It looks the same when I put those, so it doesn't. So am I just looking for it where it like touches the y-axis, or?
Yes, exactly. Yeah.
So can't you do like second trace 0?
Sure. Yeah, that's another option. I didn't think of that, but yeah, third option is to use a second trace, especially since you've got multiple choice in yours. You know, a lot of times students have to do this.
Wait, so
by
then
hand.
second trace, value. No, yeah, no. But that gives you x. I don't want x, I want y, right?
You put in an x.
Put it as x equals 0.
Well, it'll tell you it's undefined though. So you have to pick something really close, like 0.001 or minus 0.001.
For 0, like for a 0, you mean?
As the x value of trace.
(0.001).
Yes.
Negative 3.99799.
Right. So what's that?
So it's approaching 4. Negative 4. Right?
Yeah. Yes. And that's the correct answer.
Oh, okay. So I like that. I'll just do 0. I'll just do 0. But
let's say it was
how did you know to do like 0.00? Like why did you choose those?
so it's close to this number here.
Oh, okay.
And you want to do one on either side just in case like only one side works.
Oh, okay. Yeah.
And you know, that's another issue. I mean, there's so many, you've heard me say like exceptions or extraneous stuff, like there's way more when you get every level of math higher.
Right.
So like we can't go through all of those, but there are other possibilities here that we're kind of ignoring.
Okay. Sounds good.
Okay, you're going to be well prepared for your retake.
Thank you. Thank you for your help.
And, you're welcome. And thanks for scheduling, and I'll see you next time.
All right. Bye. Thanks.
Have a good day. Bye now.